Yes, class. Good evening. Am I audible to all of you?
Yes, ma'am, you are.
Okay. Terim, I think you have texted me on WhatsApp no regarding the notes.
Yes, ma'am, I have texted.
Okay. Okay, Terim. After the class, no. I'll share all the notes with you, not just for the 2 lessons, for the first 5 lessons, self work, energy,
Yes,
and power.
ma'am.
All right, and I'll
Okay.
share the video lectures also because on Fridays I'm having so many classes that I'm not able to take your backup class, and on Saturdays and Sundays you people have your bio or maths class. Some class you all have on Saturday and Sunday, so that's why we are having difficulties in this backup timing. As soon as we'll get, I'll arrange it. But I think for the timing, you all should start watching up the backup videos. But by just seeing the videos, you will be able to understand many things. If you are having any difficulties while watching the video, in that I can help you easily. Otherwise, whenever I'll get time, I'll arrange a class for you. Okay, so gravitational field we did. Gravitational field we had covered. Gravitational field outside for hollow spheres we had seen. And gravitational field intensity totally we have calculated. Gravitational field for a point mass we didn't calculate. This was one topic that was left. Then we'll move on to gravitational field energy. So we are towards the end of this lesson now. Escape velocity, orbital velocity, and few basic things like Kepler's law, like these terms are left that we'll do in the next class only. Gravitational field in the next class. Next class I have to take a 2-hour class because in the next class I have to complete with gravitation. Otherwise, your syllabus will lag behind. So I'll start the class from 7 IST. So accordingly, please see. So what should it be? If it's 7 p.m., 4:30, 4:30, no? 4:30 KSA timings. So all those, just the IST 7 o'clock, basically 2 hours class, half an hour before on Wednesday, I'll start. Okay, class. So gravitational field for a point mass. Now, see class, capital M is there. We used to call it as the source mass. Right, this is the source mass. Then to test this, whether any force is acting on this or not, we had a test mass. This is the test mass. There is a separation between both of these R. So gravitational force was capital G, capital M, small m by R square. Fine, this will be it. And if you find out intensity, we did intensity will be this, we have seen intensity will be what? Intensity will be G, capital M, small m. Basically, it will be force divided by small mass. So R square by M. This is how you get the formula G M by R square. So even if it is for a point mass, same calculations you have to do, same performance you have to. So just remember, direction of gravitational field is towards the source mass always. This will be towards the source mass minus R cap. Also you can put, just remember the direction. So direction will be towards the source mass, which is producing the force, not the mass that is given to you or assigned to you, towards the source mass. This I have made you write separately because separate question also for 2 to 3 marks can come. So that's why just note it down and we'll start with energy. Written?
Yes, ma'am.
Okay, now let's start with gravitational potential energy. So see class, the way in work, energy and power, we had seen the relationship between work done and potential energy, same thing you have to apply. That's why we had all these lessons before gravitation. What was work energy theorem? What was meaning of potential energy, meaning of kinetic energy, total energy, everything gets utilized. So here also potential energy will be calculated by work done only. Whatever will be the work done to carry a point mass from the earth to infinity, that whole work done will be converted into potential energy. So that is potential energy. This derivation is there in your syllabus. See, let's say earth is there, mass m. So earth is there, mass m. Suppose I'm taking a point here, this is some point P. Here from this point P, I am taking this mass m to infinity. I am taking this to infinity. Fine? Infinity point P. In between also, if I take 2 points here, let's say A, B. So this distance will be very small. Let's say dx. Distance will be very small. So work done in carrying the mass m from infinity to point P. I am bringing the mass m from infinity to this point P. All right, this is actually equal to potential energy at P. Work done in carrying from infinity to P is actually equal to potential energy at P. This is the basic crux of the derivation. Now see gravitational force at this A point, if you write it at this A point. So force will be what? See, capital G will be there. Here you have M mass. Imagine you have M mass right now here at this point A. So capital G, value value of the mass of Earth. So M1, value of the mass that you are carrying, small m, divided. Let's take this separation as something. From A to M mass, let's take this as x. So x squared. Fine, this is this point P, let's take it as R so that you get a clarity of what we are taking. R is separation of point P from Earth. This is some point A I have taken in between. In between I have taken. Fine. So now work done in carrying mass M from this A to B point. Work done in carrying from A to B. If you calculate, so dW will be equal to F dot dx. This is what? This is gravitational force at A point. So this will be F dot dx. Fine. Cos theta will obviously be 0. See, displacement is in the opposite direction occurring and force is occurring in the opposite direction. So even if you write F dx cos 0 degree, this will be F dx only. Now see class, write down everything. Write down the value of force. G capital M small m by x squared dx. Integrate it. Now from where do you have to integrate it? You are bringing it from infinity to this point P. So separation of first point. This is your first point from Earth is infinity. Separation of second point, that is P from Earth, is small r. This is basically what you have to integrate. Till this step, all your physics was required, all your knowledge of gravitation was required. Now, once you have reached this formula, W is equal to integral G mm by x square dx, integration from limits infinity to r. Now you can simply integrate it. Integration we all have studied. So now see, constant term is capital G, capital M and small m. This I'm keeping aside. I have x to the power minus 2 dx, integrating it from infinity to r. So let's integrate this. So capital G, capital M by small m. this will be, see, just whatever you have, x to the power n, just add 1, whatever is the power. So minus 2 was there, add 1. Now whatever you get in the power, keep it in the denominator. So minus 2 plus 1, this you have. Keeping the limits from infinity to r, we get capital M, small m, g. This will be 1 minus 2 minus x, no, x to the power minus 1. And 1 minus 2 will also be minus 1, integrating it from infinity to r. So we'll write this as minus g mm. Work done. This will be C, minus capital G, capital M, small m. I can write this x to the power minus 1 as 1 by x to just eliminate this power, and negative I've already written here. Fine, class, because x to the power minus 1 is there, no? So instead of writing this, it is better I bring it in the denominator and it becomes positive. Now see, class, it's better to integrate. It's easier to integrate it. This part you can write. Now put upper limit minus lower limit. C, class, 1 by infinity. What is the value of 1 by infinity? Is there some value? Yes, Waziha?
Ma'am, it was 0.
0. Correct. 1 by infinity is 0. So since 1 by infinity will be 0, you will be left with work done is minus g, capital M, small m by r. And this entire work done gets stored in the form of potential energy. This is the concept that you have already studied. Now you are applying it. So work done gets stored in the form of potential energy. So now this entire formula, W is equal to minus gmm by r, this actually becomes the formula of potential energy. So force was minus gmm by r square and potential energy is minus gmm by r. Fine? Or whatever be the mass, let's say any mass you take, m1 is there separated from m2, separation is r. So potential energy would be minus g m1 m2 by r. Like this you have to write. Now see, class, we are getting this negative sign through our integration. This negative sign actually has a significance. This negative sign basically shows you that the forces are attractive. In the sense, like, let's talk about charges. Though charges are not part of your syllabus now, that you will study in class 12, 2 charges are present. Both can attract also, both can repel each other. Magnets, north pole can repel, north south will attract. So magnets can repel also each other, attract also each other. So magnetic force, electric force, all these forces they can be attractive also, they can be repulsive also. But whenever you get negative sign, especially when your potential energy is negative, then that signifies that the potential energy is bounding your system. It means the forces are, whichever forces are involved, that are attractive. So here gravitational force will be attractive. So this negative sign is basically signifies that forces are attractive. Means they'll attract each other. They'll move towards each other. They'll allow the objects to move towards each other. And whenever class forces occur, there has to be a presence of potential energy in the system. If let's say you suppose one question comes in your theory, those conceptual questions that comes in the paper, in that sometimes it is asked that if the separation is infinity between both the masses, let's say m1 and m2 are present, they are having separation infinity. So what will be the potential energy? Will it be maximum, minimum? So see, minus g m1 m2 by infinity, as Wazir rightly answered, 1 by infinity will be 0. So potential energy will also be 0. See, this is the highest value of potential energy that is possible. Otherwise, rest of the values were in negative. Right? Mass cannot be negative. Capital G cannot be negative. So formula will always stay negative. So this is the maximum value of potential energy that is possible. So if you are asked a derivation do come, class. This derivation comes in your paper, write the formula of gravitation potential energy. So do it till this step. Till here, you have to show. If a question comes, use this. If it is asked to write about negative sign, always remember attractiveness it shows. And this can be asked to you in your theory type, not like this diagrammatically. It will be asked if the separation between both the masses is increased to infinity, what happens to potential energy? Will it be minimum, maximum? So it will be maximum and it will be 0. Tell me, class, is it clear till here? Jania, Abdullah, clear to all of you? Safura?
Yes.
Yes, ma'am.
Okay, note it down. Then we'll practice a question on this. See class, whenever work, if you are asked in the question, no, calculate the potential energy to make the system or calculate work done to make the system. If in the question you say work done to make the system, if you see this word, then the work done will be exactly the value of potential energy. But just in case, if you get work done to break the system, then your total work done will be negative of potential energy. Just keep this in mind. Now let's see a question. 1 or 2 questions, let us practice. So this is body of 2 kg mass. And then here you have 3 kgs separated by 10 meter. You have to calculate first the potential energy of the system. Secondly, you have to calculate work done to make the system. And last part, work done to break the system. Then we'll see some other question. This is a very, very basic question just to get familiar with the formula. So potential energy's formula is capital G M1 M2 by R. Capital G is minus you'll keep, then value of capital G 6.67 into 10 to the power minus 11. First mass 2 kg, second mass 3 kg. C class, M1 is 2 kg, M2 is 3 kgs, and their separation is 10 meters. So divided by 10. So this will be around 37 something, minus 37 into 10 to the power minus 12 joule. When you are writing, no, just also calculate and let me know if it's correct or not. I've just done it orally. Because 12, then because 6 into 6 C class, this is 36. So, and since this is not exactly 6.67, so it should be around 37 something. This I have rounded off, that's why I've written it. Otherwise, if you get precise answer, let me know, I'll correct it. Second part, work done to make the system. See, work done to make the system is exactly equal to potential energy minus 37 into 10 to the power minus 12 joule. But third part says work done to break the system. When you have to break the system, you have to write negative of the potential energy. So that will be plus 37 into 10 to the power minus 12 joules. Very basic question. Now you'll get these kinds of questions also, but many a times we have the patterns like 2 masses are given in the form of square, 4 masses are given on the vertices of square, triangle. So we'll practice for rectangle or square so that you'll be able to deal with others. So note down this question, then I'll give you one more question. C class, 4 point masses are given to you, their separation is given. And now you are asked to calculate potential energy of the system. C class, what did I say? Whenever you have potential energy, you have to see number of interactions that are occurring. It means number of forces that are occurring. So see, two bodies can interact with each other. It means they can exert force on each other. Two bodies that have certain separation. So according to you, in this figure, if 4 point masses are present on the vertices of square, how many potential energies will be there? Individual potential energies, according to you. Just the number that we'll calculate. Like M and 2M will have one energy, M, 2M. Then according, you can say M and 4M will have one energy. So like this, how many number of energies? Class. Talha, Waziha, Tehreem, Safura, Abdullah, Tarif, Jania. Some idea you can have? Or you have understood nothing? I'm giving you one hint. M and 2M, this will make one energy. So how many energies will be there?
Ma'am, 4.
4 says Tehreem. Okay, at least she answered. Others?
Ma'am, 2.
2. Waziha says 2. Rest of you? Anyone who has a different answer? Or the same? 4. Talha says 4. See, those who are seeing 4, you people are calculating M, 2M as 1, 2M and 3M as another 2, 3M and 4M energies as 3, and 4M and M energies as 4. Am I right? Waziha, Talha, not Waziha, Tehreem and Talha? Like this?
Yes, ma'am.
Okay. C class, thing that gets missed in the exam is that 2M and 4M are also in contact with each other also, no? So M and 3M and 2M and 4M, that means 6 energies. Do not forget the diagonals. These will all, they are also interacting and they are also interacting. So that makes 6 energies. That's why I wanted others also to answer. Only 3 students answered. Anyway, so let's talk about the energy. So firstly, let's write the first one. This is the first one. Minus G to M into M by A. Second, minus G to M into 3M by A. Third energy, minus G 3M into 4M by A. Fourth energy, minus G M into 4M by A. Class, this is, one side is A, this side is A. So the perpendicular, this entire, sorry, not perpendicular, the hypotenuse of the triangle using Pythagoras theorem, it will be A root 2. One side is A, another side is A. So A square plus A square under root, that makes it root 2A. Similarly, this side will also be root 2A. So all the diagonals, these are root 2A. So calculating the fifth energy, minus G 2M into 4M by A root 2. Calculating the last sixth energy, minus G M 3M by A root. First, tell me class, any doubts in this step? If you have understood this step, then you will be easily able to answer the question. Clear to all?
Yes, ma'am.
Yes, ma'am.
Okay, good. So see, let's do one thing. Let's take minus G M square by A common, because you can see that is common everywhere. So if we take that common, and minus also we have taken common, so from here 2 will be left. Then 3 by root 2 plus 4 plus 6 by this will become 8 by root 2. This will be 8 by root 2 plus 12. This will be total value. Fine. So this you have as 12. Now see, minus g m square by a is there. If we solve, so 10, 22, 24, right? So this becomes 24 plus 8 plus 3, 11 by root 2. This entire is the potential energy. Even if now you are asked to calculate work done to break the system, to make the system, you can use this value. Note it down. Any doubt you have in any of the steps, how to solve this, please let me know. Done class or still writing?
Done, ma'am.
Okay, I think all of you have completed it. Before we start with potential, just the term gravitation potential. See, class, gravitational potential energy difference can also be asked to you. That I'm not doing in detail. Let me just tell you in brief. if a question comes, how to deal with gravitational potential energy difference. See, this was gravitational potential energy for single charge you were calculating. Like when we were talking about m and 2m, you knew this energy only. When we talked about 2m and 3m, you calculated this energy only. If this difference comes in your exam, energy difference, both of these, so that derivation actually comes. That's why I have to discuss with you. Otherwise, you can directly subtract. Potential energy difference, gravitational potential energy difference. It means here is your Earth. This is some point A where your body M is there. This is the initial point. Here you have some point B, which is the final point. This separation from A, this separation is R1, and this separation from B, this is R2. Fine, this is separation from A and B. So change in potential energy will be work done in carrying charges from A to B. So potential energy difference will simply be potential energy of B minus potential energy of A. So when you perform the derivation, when you write UB minus UA, you will be writing this is difference is actually equal to the same thing. GMM by x square dx, but difference will arise where? When you're writing potential energy difference, this means one point is not infinity. Both the points have certain values. One point to another, both will be having certain values. Like this is R1 to R2. This is just the difference in potential energy. If you had potential energy, there you were taking the body from infinity to a particular point. In potential energy difference, you are taking not from infinity, from one particular point to another particular point. So here just the difference will arise in your limits. The rest of it will be same. See GMM, here you will take x to the power minus 2 from R1 to R2 dx. So GMM x to the power minus 2 plus 1 by minus 2 plus 1, you are left with R1 to R2, right? So this becomes GMM, same derivation class, x to the power minus 1 from R1 to R2, GMM by 1 by x we can write from R1 to R2. So you put the first value as R2, second value as R1. The way where we took 1 by infinity, here you are having it as 1 by R1. This is just the difference. Rest of the thing is same class. So 1 by R2 minus 1 by R1. Here you will be having a negative sign as well. This is the final value of change in potential energy difference if 2 points are mentioned. R1 is your initial point, and this is your final point. Fine, this is all about potential energy. These questions only keep on revolving. The way we had seen this question, you can be asked to the same question on a triangle where 3-point masses are kept like this, but basic just remains the same. Note down this part as well, then we'll do gravitational potential only. This was energy, no? Then we'll do gravitational potential. And again, class, I'm repeating, these things will not leave you in class 11th only. These will be repeated in class 12th. Same things, electric potential energy, everything will be whatever term you're using for gravitational here, that time it will be electric. See, now we have to discuss gravitational potential. In gravitational potential, it is exactly similar to gravitational potential energy. Just the difference that will arise from gravitational potential energy and gravitational potential will be that gravitational potential energy was for two masses, any two masses. Gravitational potential is the work done that is carried, that is required to carry a unit mass when one of the mass becomes 1 kg. I'll tell you. Gravitational potential. So it is basically all the gravitational properties in scalar form. One thing that is important is that it is a scalar quantity firstly. So all the directions and vector laws, everything is not applied here. Even gravitational potential energy was also scalar. Did we take any direction when the question for on the square we solved? We didn't take any direction, just two charges, just two masses with their separation that we kept. Now see, what is the meaning of it? It is the work done. It is the work done in carrying. See, till here, the definition remains the same. Unit mass, this makes a difference. The rest of the thing is same. Unit mass means when one of the masses in the formula becomes 1 kg, then from infinity to any point against the gravitational field. So from infinity to point against the gravitational field. Fine. Like it means this is your M, this is your source mass, which is generating the force. The other point M, this is the value of this is 1 kg. One of it is 1 kg. And let's say in between you have taken 1 point. So if you are calculating the potential energy of mass capital M at this point, yeah, I'll write this down. If you are calculating potential of mass M at P, then see, potential will be whatever is the work done in carrying the mass from infinity to point P divided by mass. Why? Because this is per unit mass. So how do we solve in unitary method? Divided by the term. So see, if small m was 1 kg, suppose, then all your potential would have been equal to the work done. That's what was the definition I had written, that it is equal, potential is equal to the work done for unit mass. That means mass is 1 kg. So this is the formula for it. Formula, I'll tell you, one thing that you have to keep in mind is scalar. Another thing is the SI unit. C class, SI unit will be joules per kg simply. For work done, you have joules. For mass, you have kg. Now, the actual formula that you will be writing. In energy, you had G minus G mm by R, right? If you're writing this gravitational potential, if you're calculating gravitational potential of a point mass, if you're calculating gravitational potential for a point mass. So you had earlier minus G M by R. Now one of the mass is 1 kg. So formula will be minus G M by R. This will be the formula. Same derivation is there. If by chance the derivation is asked to you in the exam, same derivation you will write, but just take this M as 1 kg. Same thing you will arise at this conclusion. Even if you're calculating the potential difference, if you're calculating the potential difference, so see, this potential difference will be same. Gm, you had minus Gmm by into 1 by R2 minus 1 by R1. Here you will be just having one single mass. And if derivation is asked, same thing. You just have to substitute one mass as 1. Noted down, this is very similar to what you have just studied. Any doubts you have, ask me. Gravitational potential for spherical shell, if you are asked to write. So you will be writing the same things that you have calculated for the gravitational field part. Fine. So let's say mass is m, r is capital R, small r is the separation from a particular point. Now see, so potential at the outer surface will be minus gm by r only. At the surface, it will be exactly the radius. Outside and inside and surface both are same. So this is V surface or V inside. And at the center also the same thing. Center, inside, surface. This is just the difference that will come. But this is valid for a hollow sphere class. This is valid for a hollow sphere. If you have a solid sphere, then see, outside and surface are easy to write. Outside will be minus gm by r, and on the surface it will be equal to minus gm by capital R, the radius. But V inside is difficult. This derivation is not there a part of your syllabus, but the formula can be asked. Minus m minus gm 3 capital R cube minus small r, sorry, not cube, square we have. So 3r square minus 2r square divided by 2r cube. This is the formula for it. Usually the questions are not asked on the inside part, but by chance if it is asked, one more relation, remember that say at the center, this is 3 by 2 of potential at the surface. These are some data for spheres that you should remember. By chance if it is asked in your exam, this should not be a problem for you. Note it down quickly. Text me done in the chat column. I'll complete it. Then escape velocity, orbital velocity, all these we have to complete in the next class. So text me done once you are done.